All right, today we have 665 non-decreasing array. Given an array of nums with an integer, your task is to check if it could become non-decreasing by we define at most one element. We define an array is not decreasing if this holds for every I 0-based. Okay, and -2. So 4 to 3, true, because we can change 5. 4 to 1 and get non-decreasing array. 4 to 1 we cannot modify. So it's similar like switching 0 1 pattern. Then in this case, instead of like physically modifying and checking array every time, we just check how many inconsistencies we have in array, right? So, and we return, so we can do count, and we return if return count less than 2. If this is 1, it's okay. If this is more than 2, it's... So yeah, in this case, it will be often complexity and very easy to implement, but I think there is something wrong in it. Like, it cannot be medium that easy, right? So, okay, let's do this. Let's do count equals 0. But it's hard for me to say why this is wrong, because maybe there is a array when we still have one inconsistency, but we cannot. It's still not. Even if we fix this one inconsistency, it will not be non-decreasing array. So let's try this for C in nums. What we need index and value in enumerate, and what we have to do, we basically do this. If nums I write more than let's calculate length of the array on top nums. So if we are in a range, meaning I less than L, and we in a range, and this condition is not, and this condition is correct, right? Then we increase count, because this is in our inconsistency, right? And we return count like this. But as I said, it's probably gonna be wrong. Enumerates. No, I think it's different. Could be different. No, it's not enumerates. I forgot what it is. Okay, give me 1 second. I think it's iterate or enumerate. Yeah, it's enumerate. Why it's not working? Okay, enumerate. Enumerate. Well, that's funny. Out of range if n less than L and nums. Okay, this I don't understand. So we have index value in enumerate. We choose correct. Right? Why it's saying index out of range? Oh, okay, because I plus 1, right? I plus 1 give us L plus 1, so yeah. This is probably why. Oh, beautiful. Okay, let's submit it. Okay, here is what I'm talking about. Okay, so see, there is just one inconsistency. It's just one inconsistency, and it's not. It cannot be, and it cannot be made non-decreasing. Even if we change this, it cannot be non-decreasing. So what we like, we can say that non-decreasing array, right? Non-decreasing array is array that, so we cannot use this pattern, right? We cannot calculate inconsistency because in this case, we have to calculate inconsistency between this and these elements, right? So monotonic stack, maybe? Yeah, monotonic, I'm not, monotonic stack is not strong with it, so I'm not. But non-decreasing array is array that we can sort, right? We can sort. And this array will be we can sort array, and array will be equal sorted array. Because non-decreasing, if we sort non-decreasing array, it will always will be the same. We don't have to like, so what if we create function that will cover this case, right? Wrong answer. So if we replace 1 and sort it, it should be the same, correct? So if we have, so this, because we are getting output true, but we expected false. So we have to add extra checking. And by extra checking, I mean like, let's create function which will check our array and it return if our array equals sorted array, right? So here we can remove this element, problem element. No, what we can do? So, okay, we can become non-decreasing, but define at most one element. So if we have this array, right? What we can do, we can, if we found this guy, we can replace previous one, right? And run it through sorted or through check. Or we can replace second one, right? 4, 4. Yeah, and both will give us false and we will return false in this case. Okay, so let's see. Let's call it problem index, which will be -1 at the beginning. Pi is not like problem, PRI, problem index. So, and here we will point at our first problem index. If we found nothing, if our if tri is still -1, we will return true. Can we do like Python return true if tri -1? Okay, then no, we need it here. Then we check if we are moving forward, right? So we will be here. So we can assign pri value, which is nums pri, and we can assign nums pri equal nums pri plus 1. In this case, we will check this guy. No, not this one. So we assign pri plus 1. No, oh yeah, this one is correct. So we changed, and then we check in this case. Okay, and what we can say if check nums, we return true if check nums. Then if not. So if not, we have to assign this back, right? We have to go with second case. In second case, we assign reverse nums pri plus 1 equal nums pri, which is changed, which is priv. And then we return true if checks. And in this case, we return false. Okay. So many returns, however, so this return if we have no inconsistency. Array is consistent, we return true, that's it. Here we still have inconsistency, but now we try to replace first element and make it consistent and see if it will be consistent. And we return true if replacing of first element with second one will be consistent. Here we try second case, which is replace next element with previous element and see if array is consistent. And we return true if array is consistent. And otherwise we return false, right? We don't need to return anything. Okay, let's try. Yes, obviously. Expected else. Yeah, I don't know why, how it's return if, Python return if, Python return if, return if statement and return if, else if one. Oh, Reddit, yeah. Okay. Is it bad practice? Return condition, true, condition false. Return true if condition. But we can also return true if condition. Well, how? Return true if -1. Yeah. Come on! What's wrong? Return statement if expression else. return condition or return true if condition else false. Oh, I have to put else. Okay. Let's do the old way. Yep. This is a pretty straightforward. And we have all cases running. I forgot to add case. It's okay, we got it. Okay, so here we go, use this case. Why this one is not working? So we have 5718 expected true. So, okay. I want to see what exactly we are checking. What? It's not that water. Okay. Yeah. So we copy in 5.1 here, which is correct. And this is false. But this one is incorrect. Why? Trivial numpy and then numpy we assign the thing, and then we store pre-array value. So we assign 5178. Oh, because, but how it's, why it's false? Why it's true? Okay, how can you make this non-decreasing with one modification? So how can you make this increasing array with just one modification? How? It's like we have to change 7, right? Oh, if you change 5778, yes. So we change in 1 to 7. Oh yeah. So here I have to do like this. I have to restore PRI value and I have to do like this. Yep, that's my mistake. Let's run again. It's submit. Yay, 5%, OMG, okay. So it's probably all checking stuff. Checking arrays are not good. Let's submit now. And internal sum function is not good, still 5%. Oh yeah, I have to break here. I don't have to go through array. If I found inconsistency, I just break. I'm sorry. Oh, still 5%. Okay, I'll take it. Uh, let's say optimize it a little. Can I optimize it? Yes, no. It's just one operation. Ah, still 5%. It's fine, I guess. Let's see how the faster thing. Check possibility. Okay, so if count equal 1, return. Oh, so there is a count. Okay, if count, return false. Huh, interesting. If they return false right after count found 1, yes, this is the same. Okay, that's smart. They are also updating this, but not if I equal 1 or num_i more than plus 2. Yeah, this is cool. All right, yeah, we solve it. Not the most efficient way, but that was solved, which is good. And that's it for today. Thank you for watching.